Hello everyone, my name is Sebastien, and I'm one of the founders of Pima Studios and DC Spark. And this is a whiteboard video to talk about our work to combine Cardano and Arbitrum together into single applications. So you can have a single app that leverages both protocols. Now, why would you want to do this? Well, Arbitrum is actually a really cool protocol. It's got really fast block times, relatively low fees, really fast finality, and most importantly, it's got a lot of users and a lot of liquidity. And since it's EVM based, it makes it very good for DeFi. So this is a layer 2 for Ethereum, in case you didn't know. Now, of course, EVM has a lot of liquidity and users and great for DeFi. So it's got a lot of benefits. But Arbitrum is also working on extending beyond just EVM and also supporting other kinds of smart contract platforms, but they're all in the accounting model. Now, Cardano has a different model, which is UTXO based, and UTXO has different interesting properties. Especially one of the things that I think is really awesome is that it's usually much safer for users. For example, if you're an everyday user, you're not a crypto native person, and you're holding an NFT, for example, on the EVM side, the NFTs are smart contracts. And so you're not holding the asset directly, you're using arbitrary code. It makes it very easy to accidentally lose your NFT in a hack without realizing what happened. It makes it very easy to make malicious NFTs that steal user funds. Just the fact that everything is contracts by default, although it ends up being, a very simple from a protocol perspective, it ends up, adding a lot of user risk. In the UTXO model, like Cardano, user assets are not smart contracts. They're enshrined into the protocol itself. So it means that you own the tokens directly inside your wallet. They're not smart contracts. And if any protocol wants to move funds, it's very easy to see from any wallet, any tool, any explorer exactly which funds are being moved and how. And so the fact that UTXO has these properties makes it, very easy for humans to kind of debug visually, which is a great property to have, especially for retail heavy use cases like games. So both protocols have some pretty cool benefits, UTXO and accounting. There's been a long ongoing debate in the blockchain space with some protocols like Ethereum picking accounting style, other protocols like Bitcoin, Cardano, and Fuel picking UTXO side. And we want to allow in Pima is to basically leverage both together into a single application, so you can target the full crypto ecosystem instead of just the single community. So the way we do this in Pima is that we allow developers to write their applications basically as a state machine. So if you don't know, a state machine is basically a way to represent the way a computer program works. So you can say, okay, the application starts in one configuration, and then maybe the user, if they say like move left, the application transitions to this state. But if they say, for example, like move right, it transitions to this state. So it allows you to basically reason about how your program is evolving over time based off the actions that happen inside the application. So you can imagine this is an easy way to visualize how software works and the implications of various, different actions that might happen in your application. So this is what a state machine is. And Pima allows you to take these state machines and turn them into a layer 2. So this is the Pima engine that's allowing you to turn these state machines into a layer 2. Now, when I say layer 2, it means that the data has to be stored somewhere else. So for example, for Tarochi, which is this on-chain RPG game we created, we store the data to Arbitrum through a layer called Xi, which is a layer 3. So we store that to Arbitrum, and then Xi has its own kind of data availability committee for some extra stuff here. And so basically the way this works is that we've created the state machine, which is the Tarochi on-chain RPG game, and then that gets deployed to the Arbitrum community. And what we also want to allow is that we want to allow connecting not just to Arbitrum, but also connect it to Cardano and potentially even leverage both at the same time. The reason why is because although Cardano has some interesting properties as a UTXO model, it turns out Cardano does not allow storing a lot of data, and so that makes it hard to build like a large scale game. And also Cardano focused a lot more on decentralization, and so the block times are a bit slower and the finality is a bit longer, and so that's also not super great for games. And so it makes sense to say, okay, well, we can build a game that, connects to Cardano, or an application that connects to Cardano, then leverages Arbitrum or maybe Xi or some other system for cheaper data, faster finality, and all these kinds of things, while still being able to, connect to Cardano at the end of the day. So what we're essentially creating is this way to connect the state machine to both protocols at the same time. And so we've been working towards this for the past few months, and we are planning to get this integration connected, hopefully around mid-January, at the very least before the end of January. So what does it actually mean to connect both of them together? Well, basically we want that whenever something happens on Cardano, for example, somebody buys an NFT or moves some assets, your Primus state machine can update. So you'd have, some state transition says like user bought NFT. So whenever they buy an NFT on Cardano, your state machine updates based off those actions. And similarly, we might have, some other state transition based off something that happens on Arbitrum. And so we want, these state machines built as this layer 2 to be able to react to events on Arbitrum. Now, we are working in two different work streams in parallel. One of them is to make the state machine, update based off actions that happen in Arbitrum. The other one is to make the state machine update based on things that happen in Cardano, so that no matter which layer the user is on, the game can still update based off it, which adds some really cool properties, because it means like for Tarochi, this on-chain RPG game we're building, a user could be playing on Arbitrum against a player on Cardano, and they're playing the same game world, playing against each other, but through Pima, like this difference of layer, kind of gets abstracted away. And so when you're a Tarochi player, you can choose where you want to mint your monster, which NFT you want the layer to be on. And so this creates a really cool abstraction where you can have different players from different ecosystems coming together. So that's what we've been working towards. And when I say we're going to try and complete all this work by January, of course, this is just V1. We have a lot more work planned, but this is just kind of like the initial release. So how do we actually connect these in practice? What kind of information do we want to connect from Cardano? So if you think about a game like Tarochi, and let me just give you a basic explanation, because, although Pima is not just for gaming, you can build any kind of application you want. I think this is kind of like an easy to understand use case. So inside Tarochi, you have, monsters and items. So you're playing the game, and this is like an RPG game. So you capture monsters that get added to your party, and then you have items for these monsters that you can consume inside the game, like health potions and so on. Now for Tarochi, by default, these monsters and items as part of the game are not stored as NFTs. Rather, they get stored as call data inside Xi, which is this layer 3 for Arbitrum. So the reason we did it this way is that way when you are a user playing the game, you don't have to mint the NFT right away, because if we tell users like, okay, you gotta mint an NFT to start playing, they tend to just like exit the game because it's like too much. They just want to enjoy the game, and if they really want an NFT, they can mint it later. And so we allow them to just play the game, not have to worry about the NFT generation, and we want to allow them to create the NFT after the fact. So what that means is they say, okay, this data that I just stored after the fact, now turn this into an NFT that is not on Xi, but instead on Arbitrum or perhaps on Cardano. So you want them to have this call data on Xi and turn it into an NFT on Arbitrum and Cardano. So to do this, basically, we need two different things from Cardano. We need the ability to have delayed asset check. And I'm going to explain what this means in just a second. And then we need to be able to track mint and burn events. Okay, so what do we need these two things? So you need mint and burn, because when you're creating an NFT on Cardano for your monster, you're basically taking that monster outside of the game state, putting it inside a bag that you could then sell on JPEG Store or any of these Cardano NFT marketplaces. And then when somebody opens the bag, they would get rewarded by receiving that monster or that item inside the game. So you're basically like minting and burning Cardano NFTs that represent these bags that are your monster state that you list on the marketplace. So that's why you need the mint and burn events. And we need the delayed asset check because we want to be able to know from the game which bag you still own. So you can show it in the UI that you can now open a bag or create a bag and so on. So why is it called delayed? So what is the delayed and delayed asset check? The reason is because Cardano and Arbitrum have different finalities. So remember, with blockchains, things are not finalized right away. It might take a little bit of while for all the information to propagate across the decentralized network, and for everybody to, reach consensus on the current state of the network. Now, finality in Cardano can be a few minutes. Maybe like 3 minutes, for example. It's probabilistic finality, kind of like Bitcoin. So it's never like 100% final in a way. But it might take 3 minutes, for example, whereas Arbitrum might take like, if you're waiting for it to settle on Ethereum, quite a while. If you're just waiting for it to settle on Arbitrum itself, it's just a few seconds. Maybe you could say like 5 seconds. So it's just more than what is in practice because of their current model, but that might change in the future. So you can just say, okay, maybe 5 seconds. It could be lower, but let's just say. So obviously these are like very different numbers. And so you cannot have kind of like the Cardano state change the game state right away, because then it would become finalized on Arbitrum, but then Cardano might roll back. And so the data that you used might no longer exist. Now you're selling data to Arbitrum that no longer exists on Cardano. So as you can see, there's kind of like a mismatch in the block times and finality that causes some difficulty in synchronizing data. And so when I say, delayed asset check, I mean, we can allow the state machine to know you own an asset, but it's only gets updated a few minutes behind. Like, it's not real time. It means that, for example, like if you send an asset out of your wallet to somebody else, the game would see that this happened. We would see this happen after Cardano's reached finality, which might take a few minutes. And so this is what we mean by delayed asset check. Now we'll talk about our solution for getting around this problem in just a minute. But hopefully you understand that for this use case at least, these two things are what's required. Now, we have this already implemented, and we are working on, that's not check. We're still working on this other one. So that one's like a construction sign. So how do we actually build these in practice? There's an indexer called CARP, which is managed by DC Spark, and CARP is a Postgres indexer for Cardano. So basically, you have these Cardano blocks that come in and get created every 20 seconds in Cardano, and then those get fit into an execution plan in CARP. And basically, what these execution plans in CARP allow you to do is say, okay, for my indexer, instead of indexing all of Cardano, which is like too much data for a game, because then the node requirements for a game get really, really big, you specify exactly what kind of data you need for your game. So you could say like, okay, first, let's take a different color. First, like I'm going to index the block, and I'm going to index like the transaction, and then maybe like the assets. And then within the assets, I'm going to check like the specific NFT. So CARP allows you to create the execution plans to find exactly what part of a Cardano block you're interested in and throw away everything else. So it allows creating these like really slim indexers that take very little space and very little memory requirements. And so we've been adding these tasks to CARP for, delayed asset checks and mint and burn. That way, as a game developer, if you're using PineMine, you're building your state machine. You're saying, okay, I'm building a state machine. I want to connect it to Cardano. I want to have the delayed asset check and the mint and burn. Which NFTs do I want? You end up creating a configuration file. So you say like, I want to have like a delayed asset. And then the asset has this policy ID or the smart contract address. So PineMine allows you to create configurations instead of having to program all this as a developer, which is, would take a lot of time and would reduce the accessibility of PineMine a lot. We instead just have this as a configuration file. So in PineMine, you say, okay, I have a configuration file. I want a delayed asset. Here's the policy ID for it. And then the goal is that PineMine engine reads your configuration file, sets up your state machine for it, and then we will eventually connect this to CARP so it can spin up a CARP instance for you that indexes exactly the information you need just for your game. And so through the system, it means that as a developer, you don't need to know how Cardano works. You don't need to know how Arbitrum works. You don't need to know how all these different smart contracts work. PineMine just sets everything up for you, and then you're good to go right away. And so that's kind of what we're working towards. Now, there's other stuff in Cardano you might be interested in. So for example, we are also working on detecting Cardano stake pool delegation. And this information would also be, something you can specify inside your configuration, inside your Pima configuration. Okay, for my game, I want to say that the game gives you a special in-game reward if you're delegating to my stake pool and these kinds of systems. So for Cardano stake pool delegation, we've also already created the carp task for it, and it's already integrated into Pima. So delayed assets is fully done. We have a carp task for it. It's implemented into Pima. It's already working. Mint and burn is still in progress, and Cardano stake pool is also already done. We'll have more updates for this, but at least like a V1 is done. Now, as I mentioned, right now we support delayed systems, which is like it's not real time. We're also working on a different project in parallel called projected NFTs, which are different configurations. So you can say, okay, maybe I want the delayed assets, maybe I want the projected NFTs. You can choose as a user which one you want. The projected NFT is basically like a time lock. So how that works, and I'm running out of space, let me just scroll a bit. So you have an NFT on Cardano. So this is you. And you put your NFT. This is a really bad spelling, sorry. You put your NFT inside a smart contract. So you have your smart contract, and the smart contract basically locks your NFTs. Your NFT lives inside it. Now your NFT lives inside it. You at any point, and you alone, can take the NFT out. Okay? So you're putting the NFT inside smart contract, and you can take it out. So this is not a bridge, and you're not giving up custody to anybody. This is the box you can put in and take it out. Now the important point is that we've set this up so that when you're taking this NFT out, there's actually another box where your NFT is still stored inside, and then you can take it out. So why do we have this extra box? This extra box essentially acts as the time lock. So it might say like you need to wait 5 minutes to get your NFT out. What this means is that you as a user can lock your NFT anytime. Once you've locked your NFT, you can unlock anytime, but doing the unlock triggers a timer, a 5-minute timer, for example. And after the 5 minutes passed, then you can take out your NFT. The reason this is useful is because remember that this system basically allows you to bypass the finality. This means that even though Cardano has this long finality period and you're not sure if the user still owns the NFT or not, through this predicted NFT system, because like it enforces 5 minutes before you can transfer your NFT to anybody else, it means that Arbitrum or any game leveraging another layer 2 can assert that you still own the NFT right now. And it's no longer a delayed statement. It's now you're saying the person owns the NFT right now, right at this instance. And you know it because if they tried to take it out, it would start this 5-minute timer, which Arbitrum would have time to react to. So this projected NFT system, we already have the carp task for it. We already have the Icon smart contract. And actually, we have an EVM implementation of this as well. So we have Solidity smart contract. We also have a dApp for this. So we actually have a website where you can manage your projected NFTs and see all the NFTs you've projected to which game. And then we have the Pima integration done as well. So we've already basically wrapped up this projected NFT project for a lot of the feature, and we're just doing the final work. Now, what is this final work? What is remaining on this project? So as a developer, if you want to create a game, you often need really custom data formats. So you might say like, okay, I have like a player, and the player has health points, and the player has maybe attack stats, and a whole bunch of other stuff. So you have these custom data structures you want to set up, and you want to figure out how do we represent these inside Cardano. Now, of course, this is possible, but if you're not a developer, this is not immediately obvious. You can, of course, use libraries like CML and Lucid to try and create these custom data formats, but it requires, a deep knowledge of how Cardano works and how all these systems work in Cardano. And so trying to define these custom formats is a little bit difficult. What's even worse is that, like, once you've defined your custom format, now you need to go create your indexer for it. You need to create your WASM or Rust SDK for it. You need to go create your JavaScript SDK for it. You need to create your dApp for it. Like, you end up having like so many things, so many steps required just to represent like a single player, and then you have to do this all over again for a monster, and then have to do this all over again for the map data, and then do this all over again for the buildings, and like it's not scalable, right? So at DC Spark, what we've created is a tool called CDDL CodeGen. CodeGen. CDDL CodeGen is a way to automatically generate code from specification. So instead of having to represent all this as like a text file, you can instead represent this as a specification. So you say, okay, the player is a combination of health and attack. And then, like, what is attack? It's an integer. So you end up, defining like a specification file for this. So it's a way to describe the exact data format. And through CDL CodeGen, we can take your specification and automatically create a Cardano library that contains JavaScript SDK, a Rust SDK, a WASM SDK, and a JSON definition. It means that now the time it takes to build this kind of like custom system for your game, was shrunken from taking days to potentially just, minutes. You just specify what you want. And, this day and age, you can write these kinds of files with ChatGPT very easily. So you write your specification, and then CDL CodeGen will take that and just generate all these files for it. So what that means in practice is that now, if you wanted to create a system for your game, you can easily create the custom metadata for it. Then you can just connect that to Carp to create the indexer for it, and then connect that to Prima so you can read from your game state, and now suddenly everything is connected. So this is basically what we've been building towards. So now you can easily create, these kinds of complex applications, be them like carbon credits or commemorative NFTs or traceability, or be it, games like Tarochi. And as you build these games, you can have the assets live on Cardano if you want, but of course, as well, you can have assets live on Arbitrum. And so that's how we're kind of connecting these two together. Now you might be wondering, well, okay, so it's cool that we can react the information between these, and we can react information between these, but how do we actually get information across? Like, what if I want to have, user payments that work, more like a multi-chain way? Instead of having data transferred across, you want actual assets. Of course, bridges are to a certain extent an option, but we've been a lot more interested in zero-knowledge cryptography for this. Normally, we're working on Mina, but you can think about this in the same way with Midnight or Fluent or some of these other really awesome platforms. So you would do is basically you'd have, for your game, you'd have a Cardano component, an Arbitrum component, and then a Mina component. You'd have Prima in between. And so Prima would be acting as the connecting layer between these three ecosystems. So why does this actually improve the situation? Why is this not exactly the same problem we had before? So the interesting thing about Mina is that the entire blockchain is all ZK. It's all just ZK circuits. If you don't know what ZK stands for, it's a kind of cryptography called zero knowledge. Zero knowledge cryptography. And if you're wondering what the zero knowledge means in here, the cool thing is that basically you can prove something happened in the Mina blockchain without actually knowing the Mina blockchain. And I know this sounds like a crazy statement, but just for now, assume it's true because I can't really spend the entire time describing how it works. But it basically means that as you write your smart contract for your platform, you can write your smart contract inside using JavaScript, by the way, using JavaScript inside the Mina blockchain. So you specify parts of your application state. And the really cool thing about Mina is because it's all built in all using ZK, you can create a proof of the Mina state that is constant size. So the proof is always, I forget the exact size, but maybe some like 10 kilobytes. You can have a proof that represents the entire Mina state and post that state to both Arbitrum and Cardano. So you can have, you can leverage a smart contract platform with consensus in its own system and take that proof and post the proof to have that, part of your application have a financial impact on Arbitrum and a financial impact on Cardano as well. So it allows you to even have like betting systems where a Cardano player can play with an Arbitrum player and they both place bets, and then like the winner actually like makes money across. And that's kind of like what we're trying to aim to build. And so we have a blog post that describes the system that we've been working on in more practice, notably a system called Zeko, which allows spinning up like custom Mina layer 2s specialized for this kind of use case. And so you can find that blog post on the Paima blog. That's blog.paimastudios.com. But you can see how leveraging ZK now allows us to have games with financial implications across multiple chains as well as it helps a lot with scalability and private game state, which are all things that Mina supports. So that's kind of some of the future work that we're working on, as well as in this video, I talked a lot about the Cardano connection, the smart contract for Cardano. We are still doing the equivalent work for Arbitrum, and we'll try and get all those parts done as fast as we can. And we also have our eyes on some of these other blockchain communities out there and who else we might integrate with next. We still have a lot of work to do for Paima, but as you can see, we have made a huge amount of progress already to connecting Cardano to the Paima ecosystem, and the V1 of all the system, like the project NFTs, the late asset check, the mint and burn, and connecting Cardano apps to Paima in general should be all ready by hopefully mid-January. So it's a huge amount of work, but all the system I just described, from the project NFTs to even CDL Cogen and CARP. CARP is not like CDL Cogen. These are not theoretical tools that we're waiting to build that will be done in years. These are things that are live today, that we're using today, and are being leveraged in games like Torochi, and we'll hopefully have all this kind of integrated into the system, hopefully by the end of January. So it's all coming to life. This is no longer kind of theoretical technology. It's been years in the making to get to this point, but I appreciate everybody who's been with us since the start, or even if you joined partway through, and even if you're listening to this video right now, super appreciated. And all this has been possible thanks to your support. And we'll try and do more whiteboard videos like this to describe more our protocol. And so definitely like and subscribe if you want to learn more about the continued work we're doing.